Hello, so Morgan Studios. Today we're going to do work done by an electric field on a positive charge. The question is, find the work done by an electric field where the electric field is 14 kilovolts per meter. The charge is plus 1.6 times 10 to the 19th coulombs. The distance is 40 millimeters, and the angle between your electric field and your distance vector is 15 degrees. Okay, a simple fact about work done that you may already know from your mechanics classes is that when the force moves an object, you multiply the force times the distance. They have to be in the same line. They have to be parallel. But if they're in different directions, you have to use vectors and the dot product. So work is your force vector dotted into your distance vector. And you can think of it also as the magnitude of the force times magnitude distance times the cosine of the angle between your force vector and your distance vector. Okay, you can apply the same force distance concept to electric fields, but instead of force, you have kind of electrical force, which is your charge times your electric field vector, and then everything else is the same. So in the end, you get charge times the magnitude of the electric field times magnitude of distance times the cosine of the angle between the electric field vector and your distance vector. One last note, your work is in joules, charge is in coulombs, electric field is in volts per meter, your distance is in meter, and your angle is in degrees. So if you make sure your units are correct, you can then just plug in the numbers and find work. Okay, at this point, you have all the basic materials. You can solve a basic work done by an electric force problem. If you want more, click on the link down below, and I go into details of just plugging in the numbers, figuring out electron volts and all that good stuff. Okay, hope you learned something, and I'll see you next time.